to review these calculations, first I went ahead and put my equations. I'm going to provide the equations for you on the test, something I like about physics. But providing them is only the first step because then you have to know how to use them. So down here, we want to take our boxes one at a time. How can we know? I put this box here so that you could automatically go EG. Okay, where is EG? Oh, there's EG. And I'm sorry this doesn't both say EGP, but EG and EGP are interchangeable. It's the energy due to the gravitational potential. So it's MGH. We always want to look for those signs so that we can, for the same letter somewhere else, so that we can find out what we're supposed to do. So then when we're filling it in, we look for our M. Mass is almost always in the question. So mass of 4 times the gravity. G is 10 everywhere on Earth. It will only change if I ask you to go to Mars or something. And then the height. Where do I get that? Well, where's an H? Oh, there's an H. 10. So I multiply them together for 400 in this area. I don't have to put joules because it's in the top of my column. Otherwise, on the back, when we do these problems, you need to put J every time. So 400 there. And then moving on down, it's just 4 times 10, because M and G stayed the same, times the height of 7, so 280, times the height of 4. 4 times 4 is 16, 160. And then by the time it's 0, it must be 0. For EK, we break this down, 1/2 mv squared. Where did I get that? Well, I looked for EK elsewhere on the page, or in the equation section. Okay, there's an EK, 1/2 mv squared. But in this case, I can only use that for this first one because I'm not given a velocity for the rest. So I know this one is 0. So I can't go down here, I can't solve this. So I'm going to move to another area. Don't get stuck on one area of a table. Keep jumping around like a Sudoku. E total, all the energies added up. What are all the energies in this situation? Well, there's EG and EK. In this case, that's all of them. So the energies added up is the E total. So 400 plus 0 is 400. And that total amount is conserved. So the 400 goes all the way down. All right, and so then, now I can solve for EK using the idea that these two add up to this. Again, when you see something, you can't find the V. Let's look for EK other places. Oh, here it is in the total. EK plus EG must be 400. So 400 equals 280 plus EK. Or more simply, 400 minus 280 has to equal the EK. So we get 120, 240, and 400. Now for the tricky part, solving for the V. Again, how are we going to solve for V? Let's find it on the page. Okay, here's an equation that has V in it. Now normally we solve for the EK, but in this case we're going the other direction. So if our EK, what is it? For this case, it's 120. So we can go ahead and start writing this equation. We're writing our version of this equation. So the 1/2 is there. I'm sorry. The EK is 120. So I'll go ahead and write out the whole equation real quick. EK equals 1/2 mv squared. So now my mass, of course, is this 4. My EK for this situation is 120. So I have 120 equals 1/2 times 4 times v squared, which is what we're looking for. This is an algebra problem that you've done in your algebra classes. First we combine 1/2 and 4, and we get 120 equals 2v squared. And then we divide both sides by 2, and we get v squared equals 60, and we square root both sides to finish this off. So if you want to leave this as the square root of 60, I am fine with that. The number is 7.75. We do the same process here. And this is why I put this v here, is we can go ahead and do the algebra ahead of time. 1/2 mv squared. How are we going to get v all by itself? We multiply both sides by 2. Multiply this by 2. 2 over 2 is 1, so that's gone. And then we divide both sides by m. Now m is gone. Now we have v squared equals 2ek over m. And how do we finish it off? We have to square root. So v equals, and that gets rid of this 2. So v equals the square root of 2ek over m. If you want this formula on the test, you'll need to derive it yourself or pay me 1 point, meaning you cannot get a 4 if I provide you with this equation. So if we want to just go directly into this equation, we can grab a calculator and open up our square root by second here, square root, and just enter in all of our information. 2 times, what's our EK? 240 divided by, what's our 4? 10.95. Do not open the square root to close the square root, or 2 times 240 and close the square root and then divide by 4. That's not going to get you what you want. So 10.95, or we can round to 11, and then this one is 14.15. So it says to draw the velocity vectors. Now you could have just reasonably drawn the velocity vectors knowing that they must get bigger, right? And that's what our numbers showed as well. So we're just going to no velocity vector here because it's not moving yet, then a small one, a bigger one, and an even bigger one. Moving down to this, setting up these tables is the hard part. H equals. So we immediately are stuck here. We can't find H's. Let's move forward. EG equals MGH, right? Where did I get that? I looked around for an EG formula, and I found it right up here. And our EK, we'll go ahead and get that one down now, is 1/2 mv squared. And of course, this 1/2 is, I don't have a good explanation for why that's 1/2 without using calculus. You'll be given the formula. So I can solve this MGH, right? I've got an H here that's 0, so this has to be 0. My 1/2 mv squared is a little more complicated, but I have an m. Where is it? Right up here. Where's a v? Right here. 1/2 times 2,000 times 25 squared. And when I square this, I need to make sure that I'm only squaring my 25 and not multiplying first. Times 2,000 divided by 2, which is the same as multiplying by 1/2. So 625,000. And our total energy must be our EK plus EG, right? Adding the 2 up. So we get 625,000. So then we know, this is the next step here, our total energy has to stay the same. It's the same all the way down. So we can't find the EG here because we don't have a height, but we can find the kinetic using the same formula. We're just plugging in 15. So then I do the same thing down here. 1/2 times 2,000 times 15 squared, which is 400,000. I'm sorry, 225,000. And down here, it's 5 squared, you get 25,000. And so we can use this information, 0, right? We can use this information, the fact that the total is 625,000, just like we did up here. We can do 625,000 minus 225,000 means we must have an EG of 400,000. We must have an EG of 600,000. We must have an EG of 625,000. This is a crucial idea that all of our energies added up. I couldn't use H to find EG, but I looked for other places where EG was, like the total energy. So then the hard part. Now we have to solve for H. And again, I find where it is. Okay, it's here in the EG formula. So I'm going to go ahead and write down that formula. EG. And again, I may not even know where this is going when I start. This is what physicists do. We go for it. We try out some of the things that have the variables we're looking for. And we see where we can go from there. So EG equals MGH. Now I can start plugging it in. What's my EG for this box? Well, it's 400,000. What's my M? Well, let's look at our problem. Mass of 2,000. G is always 10, and H is what we're looking for. So now it's just algebra. We divide both sides by 20,000. 2,000 times 10, just add another 0 to the 2,000, makes 20,000. These all go away. We have to do the same thing to both sides, right? Divide both sides by 20,000. Just cross out zeros. 40 divided by 2 is 20. And if you put this in your calculator, you'll see it's the same. So what's our equation for h? Well, it's just the rearrangement of this mgh. How do we get h by itself? We divide both sides by mg. So h equals EGP, which is just one number, right, over mass times g. And of course, g is still 10 meters per second squared. So using that equation, EGP divided by mg, we can quickly solve for these. I do want to warn you in your calculator, if we do EGP 600,000, 600,000 divided by 2,000 times 10, we are not going to get the result that we want. Because it's divided by, it's not going to get the result we want if we just calculate that directly. We need to do 600,000 divided by, open parentheses, 2,000 times 10. Because that's the way that we combine the two, because it's divided by both. Or just use algebra. I really prefer you using algebra every time and practicing those algebra chops. So this is 30, and this is 31.25, I believe.